So yeah, let me present my screen now. And today we'll discuss only regarding the SSL handshake, and I'll show you that in the Vaishak also. I hope my screen is visible.
Yes.
Yes, it's visible.
Yeah, thank you. So yeah, SSL handshake is something stands for secure socket layer. And nowadays SSL is called as TLS handshake, which works in transport layer. And this is client and this is server. As I mentioned, when you access something, any kind of URL or any sort of application, the first check is DNS, right? So the DNS resolution is mandatory, so that for example I browse facebook.com, I need the IP address of facebook.com. If I have the DNS resolution for facebook.com, then only the first check will be completed, the DNS flow. And coming to the second one, which we will discuss this later, which is TCP. So coming to the TLS, once the TCP handshake is finished, once the communication has been established. So yeah, let me do one thing then. First, let us discuss regarding TCP. So that could be great. So as I mentioned, the first check is DNS, and the next check is TCP. So let us take the client here, and this is server. So once I have an IP address of facebook.com, so now I have to establish a communication with Facebook to exchange data. So how I will establish a communication with Facebook? That is through TCP three-way handshake. Three-way handshake. So now here this is client and this is server. So what my machine will do is, first this will send a SYN packet, synchronized packet, which is nothing but synchronized packet. This SYN packet indicates I want to establish a communication with example.com or facebook.com, any sort of URL. I just want to establish a communication. That will be indicated by this SYN, synchronize message. And the next message will be sent by the server. And in this SYN packet, there will be a multiple options here. I'll show you 1 minute. Let me open the Wireshark quickly. So yeah, here we could see one SYN packet, right? This is the TCP handshake which I'm talking about. This is the three-way handshake. The client will send the first packet, SYN packet, to the server. 165.225.122.24 is my destination, and this is my PC address, 192.168.100.103. So my laptop is sending a SYN request to the destination 165.225, and this destination is sending me the SYNAC. Okay, I am also agreeing with you to communicate. And again, my PC will send an acknowledgement packet. So here, if you could see, this is the TCP, Transmission Control Protocol. And as I mentioned, there will be a multiple options. A source port. Source port is nothing but it will communicate on. This will be a random port. Source port. It will choose any random port while communicating, and the destination port will be 80 or 443 according to the HTTP or HTTPS URL. Okay, for example, if it is a secure URL, here it will be HTTPS and that will be a 443. And this is a non-secure AT URL, hence we could see HTTP. So the TCP will include source port, destination port, and the important one is sequence number. The sequence number will be 0 for the first one. This is only I'm just showing for understanding. Again, we have to discuss regarding the TCP header and the IP header later. Okay. And the acknowledgement number will also be a 0 because the client is sending only SYN packet, synchronized packet to the server. So there is no acknowledgement from the server in the initial packet. We'll get the acknowledgement for the first SYN sent by client in the next SYNAC packet, the next packet. Server will also send a SYN to the client. So the client will give the acknowledgement to the second SYN which is sent by the server in the third packet. So the three-way handshake basically includes three steps, three messages. One is SYN, next one is synchronize plus acknowledgement, which will be sent by server, and the third will be acknowledgement given by the client. So how you will be identifying whether this is a SYN packet or not? So that is simple. We could see, I have clicked on acknowledgement. Yeah. So there will be a column called flags. We will discuss this in TCP header. So once we receive a SYN packet from any client, here the SYN flag will be set to 1. For example, if the server send a SYNAC packet, we could see SYN set to 1 and also acknowledgement set to 1. And if the server, if only the client responds to the server, we could see acknowledgement packet set to 1. So basically, the TCP three-way handshake contains only three messages. First is SYN. The client will send a SYN to server to establish a communication with the server. And the server is also sends a SYNAC. Okay, I am also agreeing to establish a communication with you. So it will send a SYN plus ACK. So SYN is something to establish a communication client have sent. So the server also needs to send, right? Okay, I'm also agreeing to establish. So for this SYN, it also acknowledge. This should also, the server should also acknowledge. And here the server sent a SYN. So now the third step is client will send an acknowledgement. These are the three steps: SYN, SYNAC, and acknowledgement. In this SYN packet, it includes source port, destination port, flags, and also there will be an option fields called MSS and window size. MSS and window size is nothing but, for example, my client PC have a capability of receiving 1 GB of data. So in the initial packet only I'm agreeing up. So okay, I am capable of this 1 GB. Please send me the data until only 1 GB in each and every packet with MSS of 1370 or 1360. It will indicate in the first packet only. So according to the agreement has been chosen in the first two packets, then only the acknowledgement will be sent by the client to the server, so that from the next packet when they were sending the data, they will re-verify these agreements, MSS, Windows size, everything, and then only the data will be sent. uh, Team, are you following or else do you have any sort of questions? This is basically, I'm just giving an idea. However, we have to discuss in depth on the TCP and IP protocols. We have to complete each and every header. How many bytes the TCP includes, how many bytes the IP header includes. These are the very important points. You understand, right? What is TCP three-way handshake? Soon after DNS, the TCP three-way handshake occurs because now in the DNS I have an IP address. So later I have to establish a communication with Facebook.com. How can I establish? Through the TCP three-way handshake. Once the TCP handshake is done, now here the SSL will come into the picture. Tim, do you have any sort of questions here? If not, I'll just go ahead with SSL. Team, I need an interactive session, then only I'll be able to understand.
Ma'am, can
At
you
last,
please?
I'll be asking that out, but please go through SSL.
Okay. Vishwa, you are telling something.
Can you please repeat once again? Because the packet sent to the server sent, how can it will be recognized that the same packet from the client side? This packet only I have to need from the destination port.
No, no, no. Initially, for example, yeah. Let me start a packet capture now. I'm just browsing facebook.com and I'm just going and just stopping this and let me filter it. 1 minute, I think it was not captured. Let me disable my proxy. So I just browsed facebook.com. Here I could see a client hello. Right, 1 minute. Let me filter it out with frame contents facebook.com. So here I have only one transaction. Right, this is the destination of facebook.com. So let me stream it. Follow TCP stream. So basically, as I mentioned, my client will try to establish a connection with this destination because as I mentioned, I already have an IP address of the facebook.com by the DNS resolution. So the next step is to communicate with the facebook.com. How I'll be doing that? Based on the TCP three-way handshake. As now, just now I said, destination port will change based on the secure protocol. As I mentioned, security is something we could see the certificate of the server. If we have a server certificate, that means we have a this is a HTTPS protocol, hypertext transfer protocol with security, and that works only on port 443. And this source port will change because it is a random port. It is not a constant, but the destination port will be same based on the communication which we were establishing. If it is a non-secure protocol, it works on HTTP 80. If it is a HTTPS secure protocol, that works on 443.
Okay.
Did you got it, Vasim?
Yes, I got it. And
Yeah,
Can you
please.
can you please give me another example, not about Facebook? Can you please search another example for that?
Sure, definitely. What I can do is let's go to Snapchat.
Yeah, Snapchats. From the daily work, can you please tell me from the daily work I have to
Go for
check.
IRCTC or any other banking.
Yeah,
Okay.
that site.
HDFC also we can go. Okay, this is also secure one. If you could see, we have a certificate,
Yes,
right? So let me stop packet capture. I already have a filter set here. So frame contents hdfc.com. So now I have a two streams, right? So we have to select the first one. And if you could see here, the destination port is HTTPS 443.
yes,
I hope you got it.
yes, I
So
got.
it is something based on the URL which you are browsing. For example, as I mentioned, when you browse a HTTP non-secure example.com, here we could see a destination port as 80 and HTTPS. As it is a
Yes,
secure one, you will be seeing as a HTTPS 443.
okay, thank you.
Okay. And again, here I just filtered, and these all are my filters. So that here I can directly see www.hdfc.com. But usually we will not be able to see that, right? So how you will be verify that from the TLS handshake? So that again it depends. So you have to stream the, and you will be seeing the complete flow from the TCP three-way handshake. Soon after the TCP three-way handshake finish, we have an SSL handshake. SSL handshake is nothing but this client hello, server hello, and later the application data will flow. Once the TCP three-way handshake occurs, then only the both the parties will exchange the real application data. So how this TLS handshake or the SSL handshake works? So basically, I have a client and server here. So what my client do is it will send, this is client and this is server. This will send a client random, some random strings, okay? Clients random, and it will send a TLS versions. For SSL, we have a TLS version 1.1, 1.2, 1.3, okay? So these versions, and we have a cipher suits. Think just give me a minute. So let me present my screen again. So you are able to see my screen, right? So yeah, the client will share the client random. It is something a random string. That might be 1, 2, 3, 4, 4, 5, 6, something. A random string will be sent by the client to the server, and also the TLS version the client is supporting. Is it 1.1, 1.2, 1.3, any version? And the cipher suits are nothing but these are algorithms which is used in encryption and decryption of data, decryption of keys. Okay, these all are the things will be shared by the client to the server. One is client random, TLS version, and cipher suit. So again, now the server will share server random. Server random, server will share the TLS version and the cipher suit. The client will provide a cipher suit list to the server. I'm capable of using this algorithm, this algorithm. It will share a list. Probably these could be 13 or something, I guess. So here it will share the list which is client can be supported, and the TLS version the client is supported. So then the server will give an agreement. Okay, I'll be sending a server random. Okay, I'm agreeing with this TLS version, and I have selected this cipher suit. And along with this cipher suit, the server will share server certificate, which we are seeing currently here on the browser. So the server will share this certificate, and this certificate contains who is the issuer, who is issuing this. This URL hdfc.com is holding, which was initiated by the DGCert organization and issued on March 5th, 2024, and it will expire. The issued period, the expired period, and also it will share the certificate. As I mentioned, this is the certificate, right? It includes the complete certificate in a raw data, which is not readable by humans. We will be having a different types of certificate decoders where you can decode and see everything, who is the issuer and which URL belongs to the certificate, everything you can see that. Just copy and paste that in the decoder, and this is the public key which is shared along with the certificate. So here the client will share server hello, it will select the TLS version, and it will select the cipher suit which was given by the client, and along with the server will send one extra which is nothing but server certificate. Once the server certificate is sent to the client will send an another random string. Another random string is called as pre-master key. Pre-master key. These pre-master key is nothing but a random string, and these key will be encrypted by the public key which is sent in the previous message by the server. So this pre-master key will be encrypted by the public key which is shared by the server, and this public key will be only decrypted by the server public key, server private key. So here in the third step, client is sending a random string which is nothing but a pre-master key, which is encrypted by the public key which was shared in the last message by the server. Here in the next message, server will decrypt this pre-master key. Decryption key. Server will be having key. Here the client will not having any sort of keys. Okay, only the server will be having the public key, and these public keys came to that when the certificate is shared in the second message along with the certificate, we will be getting the public key of the server. So with that public key, it will encrypt the random string which is nothing but pre-master key, and this encryption only decrypted by server with the server private key which already the server will be having that. These are the four steps. Once these four steps are finished, now client and server have the client random, server random, pre-master key, and server certificate. So both parties have these four: certificate, client random, server random, and pre-master key. With the help of client random, server random, and pre-master key, both the parties will create a session keys. Both will create a session keys to communicate further. So both will communicate. The data, application data will be sent by encrypting with this session keys, so that both the parties having the identical session keys, because as they have all the information, both the ends now have client random, server random, pre-master key and server certificate. So with all this, it will create a session keys, and these session keys, with the help of session keys, the data will be flow. And that is what we can see here. If you could see, I'll just expand the TCP three-way handshake, sorry, the TLS handshake, which is nothing but the SSL handshake. I'm just closing this. This is the transport layer security. SSL stands for secure socket layer, and this stands for TLS, transport layer security. So when I drop down this, as I mentioned, we could see the version which is sending by the client. So client is selecting the 1.0 and the handshake protocol. What is this? It is sending the client hello is sending, and it will send a client random and the session ID along with that client random. And as I mentioned, it sends the cipher suits. Cipher suits are nothing but the algorithms. It will be sent. Okay. And once this is done, these are the extensions we have to ignore. However, this is not required. And these are the data which is required: cipher suits, random, and session ID, and the TLS version. And if we could drop down, the TLS version is 1.2, which is agreeing upon. So here we could see the server hello. If I just click on the server hello, we could see the server random, server session ID, and the cipher suit. Here, if you could notice, in the client hello, we could see the list of cipher suits, which is sending by the client. But if I could click on the server hello, we could see only one cipher suit, which is selected by the server. Okay. And also we could see a certificate which is sharing by the server. And here we could see only two steps, right? Client hello, server hello, and later we can, soon after these two messages, we could directly see a application data is flowing. And basically this is a 1.3 protocol TLS. We could see the, which is an advanced version which we were currently using. So coming to the TLS 1.1 and 1.2, we have all the steps: client hello, server hello, later the pre-master key and the decryption, and later the session key generation. There will be a six messages. Now as it is a 1.3, all the things will happen only in first two messages. The client will sending all the details, and the server will be sharing all the details. In the third, they will derive the session keys. In the third message only, here the pre-master key is generated and everything will be happen. Soon after the third message, the application data will be sent. So as I mentioned, the supported version we could see here TLS 1.3. Team, are you following? Hello?
Yes.
Yeah, each and everything we could clearly see in the Vaishak only. Basically, this is not the process where we have to show it. So we have to directly teach you regarding the topics. But that could be better if I show you the live packet captures also, so that it will be remember. And one more thing I just forgot it here. So as I mentioned earlier also, how you will identify this is a HDFC flow only. I just stream right. This is something in some or the other way. I have a filters. In that case, I just streamed the HDFC.com. How you will identify that the stream belongs to HDFC or not? This is the basic interview question everyone will ask, all the interviewers. So let me show you that. Just give me a minute. Or else, will you guys find it out and let me know? Hello.
Can you please pardon the question, please?
Yeah. So as I mentioned, I just stream the HDFC.com, right? How will you identify that?
Bhavana, is there any network issue? Because we couldn't hear it. You.
Hello. Can you hear me now?
Yes, your voice is breaking.
Yes.
It's from beginning of the class or else now?
Now, now.
In the middle of the session as well. While you are
Okay,
explaining
okay.
about TLS V1, TLS 1, 2, 3.
1 minute. Let me quickly switch my internet. Just allow me a minute.
Yes.
Thank you. I hope you are able to see my screen. So, yeah, as I mentioned, we will be identifying this belongs to hdfc.com stream. In the client hello, we could be seeing this server SNI name indication. So, 1 minute here, we could see that. Yeah. So in the extension, as I mentioned, this is an additional information to see in depth that is actually not required, but just to need in depth information like what sort of algorithm has been used, what is the key share, everything. We could see here the server name indication, and here under the server name we could see www.hdfc.com. So this is the way we will be identifying this stream belongs to HDFC or not. So when you are attending for an interview, the interviewer will ask, just explain me the flow of any URL. So the URL first check is DNS resolution, the next is TCP three-way handshake, the next is SSL or TLS handshake. And the SSL or TLS handshake will only happen if it is HTTPS protocol. If it is a HTTP, there is a no certificate, no SSL handshake is required. SSL is something for more security. We will be using this handshake to derive the session keys. Then only to encrypt and to decrypt the data, we need a session keys so that only two parties will be knowing what the data, what all of the data we were exchanging. So with this session key, the client will encrypt the data and the server will decrypt the data. The server will encrypt and the client will decrypt. For more secure communication, the SSL handshake is used. However, we are using TCP to establish a communication first, and the DNS is to find out the IP address of any URL. Once we have an IP address, the DNS check is finished. Then we need to establish a communication, the TCP three-way handshake. Okay, we established a communication. Then we have to establish a secure communication, that is through SSL or TLS handshake. Once this is done, the real actual application data will start flow. Is this clear, team?
Yes.
Yes.
Can you please repeat that 4 steps in easy way, that client and server, the first message?
Okay, regarding SSL handshake, right?
Yes.
You are referring to? Okay. So SSL is something, as I mentioned, we'll be having one client party here, nothing but my device, and this is the server, HDFC or something, we can take it as. So one soon after the TCP handshake finish, I want to establish a secure communication so that no one can alter my data. In that way, so I'll be establishing a communication with HDFC server. I'll send my client random, there will be a client random will be sent. So for this,
What is meant by client random?
yeah, that is what I'm telling. It is a any random. It is not like it is a fixed number or something. This is 1 2 3 4 A to Z something. This is a random number. To establish a communication, the client will share the random number, and again with this random number it will share the session ID, this SSL handshake session ID. So how you will be notifying that? When I just browse hdfc.com, we have seen the two handshakes, right? Two TLS handshakes. Here you are able to see Snapchat, two client hellos. How I'll be identifying with the session ID only, I'll be identifying, okay, this client hello, this SSL handshake belongs to this session ID. So that is the reason why the session ID will also sent by the client. Client random, session ID, cipher suit list. Cipher suits are nothing but an algorithms which is used to encrypt the keys with the encrypt keys and decrypt. And the last but not least, the TLS version supported by client. Is this clear? This is the first step. Do you have any sort of questions?
All good.
Yeah, great. And the next one is the server will also send the server random string. And the server will send, okay, this is the session ID of mine. And also, I'll select one cipher suit. And okay, I'm supported this TLS version. And along these four parameters, the server will send one extra thing that is nothing but server certificate. And the server certificate will be having only this complete SSL handshake will have only for the HTTPS URLs, not for HTTP. So is this clear? The second one, the server random session ID cipher suit will be selected and TLS version and the server certificate. Only this is an extra sent by the server. Along with the server certificate includes the public key as I showed on the browser. So this is the second step, and the third step will be sent by the client. Client will send again a random string. This random string is nothing but pre-master key. This pre-master key is encrypted. This pre-master key is encrypted by the public key shared in the server certificate by the server. So once the pre-master key is encrypted by the public key, this can only decrypted by the server with the server private key. So there is no keys with the client. So the client have only the keys of server. Once the pre-master key is generated, that will be sent to the server. So now the server is also having the pre-master key. So the pre-master key will be decrypted with the use of server private key. So now the both the parties having client random, server random, session ID, and also they have the cipher suits and the pre-master key. So with the help of client random and server random and pre-master key, this will create a session keys. So actually these three will goes under the crypto hashing. So that is actually not required. So it will be going under the cryptographic algorithm. So it will become one kind of hash value. So the client will be 1234 and the server random will be 4235 and the pre-master key random also will be having 6289. So all these three will go and form one hash value 1029. So this 1029 will be with the both the parties. So both the parties will go under this cryptographic hashing with the help of client random, server random, and pre-master key. Because both the parties having now all these three. This will generate the session keys and the server will also generate the session keys. Now both the parties having the session keys with the help of session keys, the actual application data will be sent. The client will ask for something and it will encrypt with the session key, and the server will decrypt this message with the help of the session keys. This is how the SSL handshake works. Is this clear? Hello?
Yes.
Yeah.
You mean only these four messages will be happened. After that, the session will be formed.
Yes, exactly. The secure channel will be formed, and with the session keys only, the derived session keys at both the parties. With the help of those keys, the actual real data will be flowed.
All good. Thank you.
Yeah. Thank you. So, team, I hope everyone understood and clear with the DNS and also SSL handshake, how exactly the URL works in background. And I request, and also one more thing, I hope you have been already written the OSI layer assignment, right? So I'll be asking tomorrow one on one, that is for sure, on the OSI. And later we'll be having a recap session again on DNS, DHCP, and the SSL. Later we can continue one more assignment on this. I request everyone to browse some few URLs encrypted and also HTTP URLs, and just show me the flow and what you have been identified. Any two URLs. Once this is done, we can continue with the TCP header and IP header.
As you told about DNS, we should check in the Wireshark regarding browsing a website and checking into DNS about source and destination. Is that source IP and destination?
Yes, yes, you have to check. What is DNS query and what is the response you are getting? You have to check that. And once you started the packet capture while replicating, like while you're browsing HDFC or something, once you have done that, you can stop here. There will be an option called stop. So here it is in blue right now. Once you have been started packet capture, you have to stop it and later just save this. And you can open it and you can see the complete flow. And here the filter you can use is direct DNS. Initially, we used to use the frame contents, right? Frame contents is only for a URL, and that too, we can see the only from TCP flow, TCP SSL application data flow. To check the DNS flow directly, you have to search for DNS. Okay.
In DNS, what we should check regarding, like, there is a transaction ID and queries.
DNS, you have to check whether we are getting a response from the server or not, and what is the response you are getting, and is it an IPv4 or IPv6. So that is what I'm telling. Few customers or few users will come to us and they will tell the URL is not working. The first check is, first the DNS resolution is happening or not. Once the DNS resolution is happening, the next step is TCP. Okay, TCP three-way handshake is happening or not, or else server is not accepting the communication from us. So that could be the whitelisting issue again. Okay, once the TCP has been completed, next the SSL handshake. For example, if we were using some sort of any proxy, few
As you
proxy.
discussed about the three things regarding DNS and
Mhm,
three-way handshake and TLS,
mhm.
we got to know about three-way handshake and TLS. Can you please uh, tell me where we can check the DNS? Like, there is in the last there is domain name system, but we couldn't find much information that. Can you please show in the Wireshark regarding DNS?
Sure, definitely. Let me start the packet capture here. Let me refresh this once. Let me check it is captured or not. Yeah. So there is DNS query. If you could see, there is a standard query, right? DNS query for www.hdfc.com. And if you could scroll towards left, here you could see one line. You have to scroll down, and this is a response for that query. Click on that domain name system drop down, just extend and just check how many queries we are asking. Only one question we are asking, and how many answers we found for that. And do we have any sort of errors in that? No error. So we have to see what is the question, www.hdfc.com. I need an IP address of that. So answers. So here we could see these many answers. And these are the child URLs. As I mentioned, cloudfront.net. So we will be having some child URLs. The C names of that hdfc.com. So this is the IP address. And what you can do is just copy this IP address and directly search here IP dot address double equal to and that IP address, and check whether do you find any sort of flow or not. And again go back DNS. And as I mentioned, you have to just search here DNS. That's it. And just check flow of the URL. HDFC or some of the other URLs. I just want you to browse two URLs and just check whether you are getting a response or not. Just try to understand this. And as I mentioned, DNS will works on port. Do you
53.
need 53? And that is what we can see here. Port 53. So yeah, that is today's class. So I just want all you to browse few URLs and just check the flow, DNS, and also TCP, SSN handshake, and how exactly the application data flow.